Hey everyone, thanks for clicking on this video, and I really hope you learned something today. Huge shout out to my student Sid. Sid watches all of my videos. Alright, so today we're gonna learn how to make polygons using the command in AutoCAD. And after this video, the next video I upload will actually show you how to construct polygons using AutoCAD. Alright, so we enter the polygon command, and the first thing that they ask us is how many sides do you want. I started with 4. This is a square, as you can see, and they also ask you if you want the shape to circumscribe a circle or if you want it to be inscribed in a circle, right? And then you enter the radius of the circle that you want to use. So you're gonna do 3 or 4 different polygons. Our first shape is arguably not a polygon, it's a quadrilateral, it's a square, but I just wanted to show you that you can do it for a square also, and then we are going to move on to the polygons. What I'm doing here is I'm just offsetting this line so it will serve as the center point for all our future polygons. Okay, so let's go. So I'm entering the polygon command. I'm going to change the number of sides to 5. Alright, you specify the center and then you say, okay, I want it to be inscribed in a circle, and you enter the radius. It's that simple. So by me saying I want it to be inscribed in a circle, it means that a circle of radius 100 millimeters, its circumference will pass through all the external points of my polygon. Right, so this new polygon, this is a hexagon, 6 sides. And the last one I'm gonna do is an octagon. I'm gonna change the number of sides to 8. And yeah, inscribed. Good. So these are the most common polygons in technical drawing. If you exclude the square, the most common polygons would be the pentagon, which is 5 sides, the hexagon, which is 6, and the octagon, which is 8. Alright, the others are heptagon, which is 7 sides, nonagon, which is 9, decagon, which is 10, and dodecagon, which is 12. So these are our polygons. I'm actually gonna go ahead and label them, and it's just that simple. AutoCAD makes it really easy to create a polygon. All you need to do is just tell them how many sides you need, and just tell them if you want the polygon to be inscribed in a circle or if you want the polygon to circumscribe the circle. Alright, so I'm just gonna adjust my labeling here, and then to speed things up, what you do is you copy your text like this, and you just click under each shape, you press enter. And having copied it, now they are not all squares, so what you do now is you go back and you just edit the text, right? So they're all the same size, etc, etc. Following the labeling of these polygons, I'm gonna go ahead and actually draw the circles for each polygon, and so that you can see the differences between the circle being inscribed or well, yeah, between the circle being inscribed or circumscribed. Okay, so I'm just gonna make a copy of these so that I don't need to draw them a second time. And there we go. Great. So now we're gonna draw the circles. Now remember the radius, or the radius of our circle is 100 in each case. Right, so you can see that when I draw a circle of radius 100 around my square, the circle actually circumscribes the square. Likewise with the pentagon, the radius is also 100. And now I'm gonna copy this circle and paste it over my hexagon and my octagon, and you'll see that it's the same size circle for each polygon. So when you are doing your polygon and they ask you if you want it to be inscribed, they're actually asking you if you want the polygon to be inscribed in a circle and not if you want the circle to be inscribed in the polygon, right? So I just need to clarify that. So we're gonna move on now, and we're gonna draw some circles in our second row of polygons. Now, as you would have seen, I copied these polygons so they are the same size as the ones above. And in the case of the ones above, all the circles are the same. The radius of the circles are 100. Now let's see what happens when we put the circle inside the polygon. So in this case, our polygon will be going around the circle. Now, before we reveal the radius of our circles, do you think the circles in the bottom row are all the same size? Like, just look at them. Do they look like the same size? So actually they are not. So the radius of this circle is 80.94. The radius of the circle for the hexagon was 90 point something. Let's put a circle inside our octagon now. So this is 92.39, and let's check the radius of the circle in the square. It's 70.71. So it's obvious that the bigger the polygon, the bigger the circle inside. Thank you for watching. Okay, so after recording the video, it occurred to me that I did not demonstrate the polygons with the circumscribe option. So I'm just gonna do that now. I'm not gonna do the square this time, starting with the pentagon. So in the earlier in the video, you would have seen me select the inscribe option, and I explained all of that. They're actually not inscribing the circle, but the polygon is going inside of the circle. So now what we're gonna do is we're gonna keep the radius of the circle the same. Each circle is gonna have a radius of 100 millimeters, but we're actually gonna put the polygon around the circle. So when we select circumscribe around circle here, that's exactly what it means, right? So our first shape was a pentagon, 5 sides, and then who could remember how many sides the hexagon has. Yep, hexagon has 6. Then I did a heptagon, that's with 7 sides, so that's a new shape. And our final shape will be the octagon, right? But the circle for each will have a radius of 100 millimeters. What I'm doing now is I'm just gonna copy the polygons that I just drew and paste them, put it over the previous one so that you can see the size difference. Right, so when the polygon is circumscribed about the circle of radius 100 millimeters, as you can see, we wind up with it's not far greater or much larger in size, but the less, my words are beating me. The pentagon, which has 5 sides, you can see a greater difference. And then the hexagon, which has 6, you see a difference, but it's less than the pentagon. And then the octagon, which has 8 sides, the difference is even less. Right? So just some interesting things for us to note. And as you can see, the circles in all of these polygons have a radius of 100 millimeters. It's the same circle. And yeah, these are just little differences and little tidbits that I think we should know, right? So it's the difference between having the polygon circumscribe the circle or having the polygon be inscribed in the circle, according to AutoCAD. Normally in technical drawing, we would say that the circle is circumscribing the polygon, or the circle is inscribed in the polygon. We're gonna spend the next few videos will be dealing with polygons. We're actually gonna be doing some construction in AutoCAD, so look out for that. And if you haven't already, please like and subscribe. Welcome back, everyone, and let me start by apologizing for not uploading last week. Life happened, and I had another project working on, so we are only able to continue our Polygon series today. And what we're going to be looking at specifically is how to draw polygons given the size of the external angle. Very quickly, for those of us who do not know, if you want to get the external angle of a polygon, you just divide 360, as I'm doing now, 360 degrees divided by the number of sides. So in this case, it's 360 divided by 5, and it's 72 degrees is the external angle, right? So that would be for a pentagon. And what I just did was I subtracted 72 from 180 because I don't want to make the mistake of doing a wrong calculation, mathematical calculation on YouTube. So I'm going to be using the calculator a lot, right? So you have the base, which is 500 millimeters, and you have the other 2 sides, which are also 500 millimeters. And once you get that, you simply draw 2 arcs of radius 500 millimeters, and then you connect them. So the base is 500, and the 2 adjacent sides to the base are also 500, and their external angles are both 72 degrees. Later on in the video, I'll pull up I'll measure the angle so that you can see that it is indeed 72 degrees. And here I'm showing you that all the sides are 500 millimeters. So this is a perfect pentagon. Alright, if you missed it the first time, feel free to go back and look at the construction again. So I'm just extending the baseline now just to create some space. And now we're gonna do a hexagon. Alright, again the lengths of our sides will be 500 millimeters, and to get the external angle we do 360 divided by 6. Alright, so the angle is 60. Let's go. So let's draw first line. The length is 500. Press tab and you enter the angle. The angle is 60. Let's draw the other adjacent side. Again, the length is 500. You press tab. 180 minus 60 is 120. Right. So we're doing quite well. And now we're onto the top half of our hexagon. Again, the lengths are all the same. Each side is 500 millimeters. And the angle entered here would be 120. Right, so once you get all the lines, you simply, not all the lines, the 5 sides, you simply insert the final side on top, and that line is also 500 millimeters. So what we have there is a perfect hexagon, and realistically it only takes like a minute to draw. Alright, so this is one way to construct your polygons. In subsequent videos I will look at other methods like how to draw it giving the radius of a circle, etc, etc. So this is our octagon, 8 sides, 360 divided by 8 is 45. So our external angle will be 45 degrees, and we are going with 500 millimeters as the length of each side again. If I am moving too quickly, feel free to slow down the video so that you can just, go through it at your own pace, or you may want to speed it up. It's up to you. Alright, so 180 minus 45 is 135. Again, I didn't want to make any errors, so that was just me pulling up the calculator there. Now the next 2 sides we're going to draw are actually vertical, so we don't need to calculate any angles or anything like that. We're just going to draw some vertical lines at a length of 500 millimeters. Right, we're in the final third of our octagon, and again this angle would be 45. So depending on the direction you're pulling the line in AutoCAD, or if you're doing it manually, the angle may be 45, or you may have to subtract 45 from 180, in which case the angle would be 135, right? And the same goes for all the other polygons. So for the hexagon it may be 60 degrees, or it may be 120 depending on the direction. For the pentagon it may be 72 degrees, or it may be 108 degrees. Also note that if the number of sides is increased, then the external angle is reduced, it gets smaller. Alright, so that's it. That's how you draw it. Again, it's pretty straightforward. What I'm going to do now is I'm just going to measure the angles, the external angles, so you can see that the math does check out. It is correct. If it's difficult for you to see the angles right now, okay, that's 72. Stick around because I'm just going to go and increase the text height. So our pentagon has an external angle of 72, the hexagon has an external angle of 60, and our octagon has an external angle of 45 degrees. Alright, again, if you do the math, 360 divided by 5 will give you 72, 360 divided by 6 will give you 60, and 360 divided by 8 will give you 45. And you can do this for any other polygon. Right, so we just increase the size of the text in our dimension line, and there you have it, 72, 60, 45, and very simple way to do your polygons, to draw your polygons. As usual, if you have learned anything, please like and subscribe. In this video, I'm going to demonstrate how to construct a polygon given the length of a side and using a semicircle. The video will be played at 1.5 times the normal speed, so feel free to slow it down if you don't understand something. The speed was just to shorten the video and to make the redundancy a little more bearable. Okay, so what we're going to do is we're going to draw a pentagon, that's 5 sides, and a hexagon, that's 6 sides. In each case, the length of each side will be 500 millimeters. So we begin by drawing a line 1000 millimeters, that's twice the length, and we're going to draw a semicircle on that line. Now what we want to do is, using the calculator, divide 180 degrees by 5 and you end up with an angle of 36. For those of us who do not know, the angle at a point on a straight line, that angle is 180 degrees. So we draw our first line, at an angle of 36 degrees. And what I'm going to do now is I'm just going to measure the open end of the angle to see what the length of it is. Alright, I'm actually going to draw a short arc here, and using the radius of this arc, right, and you get the radius by double clicking, so you see it's 309.02 millimeters. I'm just going to repeatedly draw arcs around the semicircle with that same radius. Right, so this is where the redundancy comes in a bit. Also, I did not want to skip anything out. I wanted you to see exactly how I did it, and here we have it. So we draw first arc, the radius 309, as you can see, and you continue going around the semicircle until you get to the end of the semicircle. Now you would see that I had a rogue arc a while ago. It's something that I hate about AutoCAD, but when you enter the arc command, you have to, after you enter the command, you have to press C, and then they'll be like, oh, okay, so the next point you click, that's the center of your arc. Okay, gotcha. If you do not do that, then they will assume that the next point you click is the end of your arc, and it just looks super weird. And here you can see that I'm doing it again. Right, again, as I said earlier, feel free to slow down the video if it's moving too quickly for you. So we have all of our points going around our semicircle, and this is exactly what we need. Now we're going to draw another line to the second mark along the circumference of our semicircle. And whether you're doing a pentagon, hexagon, or whatever, this second line that I've drawn, that line is actually a part of your polygon. That is one of the sides of your polygon. Right, so we're gonna bisect the two sides that we have. So the first side being one half of the baseline of our semicircle, and the second side being this line that we just drew here that I said was a part of our polygon. So we bisect these two lines, and wherever the two bisecting lines intersect, that is the center. Right, just making sure that the line is correct. Good. So wherever these two lines intersect, that will be the center of the circle, and that circle basically circumscribes our polygon, whether it's a pentagon, hexagon, or whatever it is. Right, so that's the center of the circle, and you extend it to the end of one of your sides, and there you can see the circle is circumscribing our pentagon. Now what you do now is very simple. The length of each side is 500 millimeters, so you just get your compass out, whatever you want to use, and you draw some arcs with a radius of 500. And once you have done that, you are free to now connect the dots, and you can see that it will actually end up with the form of a regular pentagon. Alright, now everything is in construction lines right now, so it looks pretty confusing. So I'm just going to change the layers really quickly so that our pentagon can stand out, and I'm going to trim the baseline so that you see our pentagon in its true beauty. Right, so I'm just going to take off the construction line layer, so the only thing that you see now is the pentagon, and there you have it. Alright, as I said, if the speed of the video is too fast for you, feel free to slow it down and go over the steps. So now we're going to do another polygon. This time we'll do a hexagon. I'm going to talk less this time. I want you to follow what's going on. So we have our base 1000. The steps are the same as with the pentagon, but it's just the number of sides now is different. So we have our first line. Now we're going to measure the open end of the angle. AutoCAD decided to give me some trouble here. That's why you saw my cursor moving and nothing was happening. Right, so we have our radius. Alright, so these steps should at least look or seem familiar to you now, because they are the same steps from the Pentagon. And of course, I made the arc error again. Okay, so what you will find is that you don't necessarily have to go around the entire semicircle and divide it up. You really just need the first two dividing lines, basically. Alright, so now we're going to bisect our two sides. So the second 30-degree line that we draw is actually a part of our hexagon. And likewise, when we did the pentagon, the second 36-degree line that we drew, that was also a part of our pentagon. And this half of our baseline is also, you guessed it, it's a part of our hexagon. Right, so we're going to bisect it just as we did with the pentagon. Just going to extend these lines so that they intersect. Extend the bisecting lines. And this is our circle that circumscribes the hexagon. Once you get to this point here, you're pretty much almost finished. Alright, so I'm going to go around the circle now, drawing arcs whose radii, well, they all have the same radius, really. It's 500 millimeters. Good. So here we simply draw in the remaining sides of our hexagon. Once we have done this, the next step would simply be to change the layer so that it stands out and so that everyone can see our hexagon. Right, so this is another method for constructing a polygon. This will be attached to the Polygon playlist. Again, feel free to slow down the video and view it as many times as you like. And oh yes, we're going to take off the layer. And as always, if you have learned anything from this video, or maybe it reassured something that you already knew, please like and subscribe if you haven't already. Welcome back, everyone. Today we'll be looking at how to make a figure larger given the length of one side. Okay, so AB is 500 millimeters and we're going to extend it by 250 millimeters, making AB 2/3 the length of the new baseline. All the other lines will follow suit, and they will be parallel to their original lines. Alright, so let's get into it. So we're extending AB by 250 millimeters, and once you have this, the length of this new line would new base would now be 750 millimeters, and all the other sides of the new hexagon will be 750 millimeters. From there, you simply extend the lines, or you pull lines from point A through to all the other points of your hexagon, or whatever shape it is. It may be a pentagon, an octagon, it doesn't matter too much. Alright, so we're going through E, come on E, behave. Let's go through E. Yeah, nice, great. I should have extended AF also, but you'll see why. And even if you forget to do something initially, you can always go back and make amends for it. So what I'm going to do now is I'm going to copy BC, as you see here, and I'm going to extend C to cut the construction line that passed through C, or the line that went through from A through C. Again, I'm copying CD, and the reason for copying it is so that we are sure that the lines are actually parallel, right? Well, we can see here that line AD, the line that passed from A that passed through D, was not long enough, so I just lengthened it a bit. Alright, great. Who could tell me what line we need to copy next? Yeah, it's pretty obvious. We need to copy DE next. Alright, so here we are, copying DE, and we're gonna lengthen it. And the reason why I lengthen the lines and pass them through the construction line instead of stopping them is because my object snap is on, and I don't want it to snap to any random point. So to bypass that, what I usually do is I will send a line through the other line that I want it to stop at, and then I will come back and trim, which, as I've said on several videos before, is pretty much my favorite command. There you go. So we're just trimming off our edges, and we are pretty much finished. I forgot to do the base, to change the base from construction to the outline layer, but I'll go back and do that just now. But you can see we started off with A, B, C, D, E, F. We started off with that hexagon, and then we were able to make it larger. Initially, the lengths of our sides were 500 millimeters, but we increased them to 750 millimeters. Alright, so here I'm just fixing up the base, and that's it.